Hello everyone. Today we're going to go over how to solve equations, but these are called radical equations. So the ones below here are some examples of radical equations. So what you should be noticing is all of these have this symbol on them, which is the square root symbol. So radical equations are equations that have the square root symbol or the radical symbol. So let's go ahead and fill in the sections in your notes. So a radical equation is an equation that contains a square root, or also known as a radical. So we have an example of the square root of x minus 3, all equal to 4. So the goal in solving radical equations is the same as the goal in solving most equations, which is solving for x, getting the x by itself, either adding, subtracting, multiplying, dividing, and doing all those things that will simplify the equation to get x on its own. So the main thing is we need to isolate the variable, and usually we use x or any other variable, but again, the goal is to isolate the variable. But with radical equations, if there is an x inside the radical, we also have to eliminate the square root. But there's only one way to move the variable out from under the square root sign. So one more time, there's only one way to move the variable from under the square root sign. And how do we do that? Is the question. So the opposite of squaring is, square roots is to square the low power of 2. So we need to square a radical expression in order to eliminate the square root. So squares and square roots eliminate one another. So squares and square roots eliminate one another. And because it's an equation, what we do to one side of the equation, we also do to the other side of the equation. So the idea is we put a square on the square root section, and what we do to the left side, we also do to the right side, using the example we were given above. So if I have a square root, if I square root the left side, if I square the left side because of the square root, I also square the right side of the equation. So again, here are the steps on how to solve radical equations. You simplify the expression if needed. You isolate the radical. So before you square root both sides, you can only have a square root on either left or right side, and everything has to be inside that square root. And then you just solve the equation like you would any normal equation after that. So let's go ahead and remember that the square root of n, we square it, and the square root eliminate one another. So that means that this will cancel with that, and it frees up the n at the bottom. It doesn't matter what's in here, as long as the square root is over it, if the square and the square root will always eliminate one another. All right, so let's go ahead and do some examples of this. All right, so here we are. So let's go ahead and this is where we left off. So the square and the square root will eliminate one another and just give me the variable n. So let's go ahead and just fill in that box. So let's cross out the n and the square root and just write here that it's n. So squares cancel square roots and vice versa. So let's go ahead and look at our examples. So example number 1, if I put a square on the left side and I put a square on the right side, then they cancel each other out, and I'm left with x equals 5 squared, which is just equal to 25. Go ahead and try out number 2 on your own. So same idea as number 1. You square the left side, you square the right side, and the square cancels the square root. And you're left with y equals 12 squared, which is 12 times 12, which is 144. Let's look at the next one. Same idea. Only difference is there's just an extra number inside, but we are good because everything is inside the square root. So I can just go ahead and square both sides. So put one on the left side, put one on the right side. And the square cancels the square root. So we can go ahead and cancel them like we did on the previous 2. The square cancels the square root. We're left with 7 plus c on the left side, and we're left with 4 squared, 16 on the right side. And now we're at step 4, which is just solve the equation. So we need to get c by itself. The 7 has to go, so I'm going to go ahead and subtract 7 on both sides. And then the 7s will cancel, and C will be equal to 9. So that's the general idea. Again, whenever you have everything inside the square root, you just go ahead and square and then move things around. So let's go ahead and move on to number 5. Again, same thing as before. We're going to square the left side and the right side. The square will cancel the square root. And then we're left with 2h equals to 36. And then we just divide both sides by 2 to get the h by itself. And h will equal 36 divided by 2, which is equal to 18. Number 5 is the first one that's slightly different. This one has something that is not inside the square root. We have this 4 that is outside the square root. So here, I cannot square both sides until I fulfill step 2, which is isolate the radical. So anything outside needs to go away first. So in general, when there's a number attached to a square root, there's like an invisible times. So the opposite of multiplication, the negative 4 is multiplying the radical. We do the opposite, which is divide both sides by negative 4. So just like if it was just 4x or negative 4x, you just divide. Now we're going to get the radical by itself, which is going to be the square root of x equals negative 7. Now that the radical has been isolated, nothing else, it's outside of it, I can go ahead and square both sides. And the square cancels the square root. So I'm going to eliminate the square and the square root. Now I have x equals, and I should have put parentheses around this. I square the negative 7, which is going to become a positive 49, because a negative 7 times another negative 7 is positive. Let's move on to number 6. Same thing again, where we have something outside the radical, which is this 5 out here. So we first have to move it to the other side, and the way we can achieve that is by subtracting it over. So I'm going to go ahead and subtract 5 on both sides. This eliminates, so we have square root of 3d equals 3. Now that the square root has been isolated, I can square the left side and square the right side. And the radical cancels with the square, so I can cross them out. And I'm left with 3d equals 3 squared, which is a 9. And then to get d by itself, we divide both sides by a 3. And my final answer is d equals to 9 divided by 3 is 3. Okay, so now that we have those done, let's go ahead and move on to our last 3 problems. So same idea, just a little bit more involved on all of these. So let's go ahead and look at the first one. So we have the 5 on the outside. This one's really similar to number 6, so it's the same idea. So try it out on your own. Actually try all the last 3 problems on your own. Pause the video and come back and check your answers. All right, now that you've tried them, let's see how well you did. So let's look at number 1. So we start with the 5 negative because it's outside the radical, so I need to isolate the radical, which means I'm going to add 5 to both sides, which gives me radical 4z equals 8. Now I'm going to go ahead and square both sides to cancel the square root. Cancel. And I'm left with 4z equals 8 squared, which is 64. And divide both sides by 4. Z is equal to 16. Let's go ahead and look at the next one. So we have something outside of the radical, so we need to isolate the radical. So we start by adding 2 to both sides. So we're left with the square root of 10x plus 40, all inside of the radical, equals 10. Since my radical is isolated, I can now cancel the square root with a square. Now the square cancels the square root, and I'm left with 10x plus 40 equals 10 squared, which is 100. Now I'm going to go ahead and solve for x. This is now a 2-step equation. Subtract 40 on both sides. and it gives me 60 on the right. Now I can just divide by 10 and wrap it up. So x equals 6. Let's take a look at our last one. Now this is a little different. We have a square root on both sides. The nice thing is everything is inside both of the square roots, so I can actually just go ahead and start squaring to eliminate the square roots. So the square root on the left is canceled by the square, and same thing on the right. Square root is canceled by the square, and I'm left with 8z equals 2z minus 24. Now I want to solve this equation. I have variables on both sides, so I'm going to go ahead and move the 2z to the left by subtracting it, so I can combine it with the z on the left side. So this cancels. We have 6z equals to 24, negative. And to wrap it up, we just divide by 6, and z equals -4, and we are done. So this is a general idea of solving radical equations. Isolate the radical and then square it. After that, just solve as regular. So go ahead and get started in your practice, and I excel, and good luck.